Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I had started the new chapter in 9th standard mathematics. That was the chapter 7, which is based on triangles. So in my previous video, I have explained about SAS axiom and I have also explained example 1 and example 2 question. So now in this particular video, we will look into the next concepts which are there in this particular chapter. So the next concept which is there in this particular chapter is Theorem 7.1. So in Theorem 7.1, here we have ASA congruence rule. So here we have ASA congruence rule. And in this particular ASA congruence rule, we have to prove that two triangles are congruent with each other if angle side angle of one triangle is equal to the corresponding angle side angle of another triangle. Then those two triangles will be congruent with each other. So now, for example, if I consider two triangles like this, angle side angle. So now if you consider the anti-clockwise, then I have to consider if I am considering this angle, then I have to consider this side and then I have to consider this angle. So here also I have to consider this angle, side, angle. So that means here angle, side, angle. So if this angle is equal to this angle, so this angle is equal to this particular angle, this particular angle is equal to this particular angle, this side is equal to this side. So if this is the case, then these two triangles will be congruent with each other. So if I consider this as ABC and if I consider this as PQR, then ABC is congruent with PQR if this particular angle and this particular angle, this side and this side, this particular angle and this particular angle are equal to each other. So you have to take angle, side, angle. So in order to prove this particular theorem, first we will take two triangles. So I'll draw two triangles image over here. So we'll take one diagram, that is, so we will take one triangle, that is ABC, and we'll consider another triangle. So we'll consider another triangle. Here this triangle is named as DEF. Now here this angle, this side and this angle I'll consider. So here also I'll consider this angle, this side and this angle. So now in the question, in the theorem, we have that angle side angle of two triangles are equal, then corresponding angle side angle of two triangles are equal, then those two triangles will be congruent with each other. So this angle side angle I am considering. So here also I am considering angle side angle. So now because this data is already given, now we have to prove these two triangles are congruent with each other. So in order to do that, first here we'll write the data which we have. Here ABC angle is equal to DEF angle and BC side is equal to EF side and BCA angle is equal to EFD angle. So now we have this particular data. Now we have to prove these two triangles are congruent triangles. In order to do that, we need to prove this particular AB is equal to DE. So in order to prove that AB is equal to DE, we need to consider three different cases. So now in order to prove AB is equal to DE, first we need to consider case 1. So now we have to consider case 1. So in case 1, directly we will consider AB is equal to DE. So directly we will consider AB is equal to DE. So if we consider AB is equal to DE, then AB will be equal to DE. So this particular angle is anyway equal and this side is anyway equal. So that means side, angle, side are getting equal to each other. So according to SAS postulate, these two triangles are congruent with each other. This is case 1. So here I am considering AB is equal to DE. So this is assumption. So we are assuming this particular AB is equal to DE in case 1. So since we are assuming AB is equal to DE, and we already know that according to this particular data which they have given, ABC is equal to DEF, and here also BC is equal to EF. So that means side angle side are getting equal for both of the triangles. So corresponding side angle side is getting equal for both of the triangles. So therefore triangle ABC is congruent with triangle DEF. This is according to SAS axiom. Now we will consider the second case. Straight away just assuming AB is equal to DE will not work. We have to prove the other cases also. Now we will consider the other possibility. So in case 2, we are considering one more possibility where we are considering AB is greater than DE. So here I'll write this particular image one more time. So here we have ABC and we have DEF. So this is ABC, this is DEF. So here we are considering AB greater than D. Here this angle and this angle are equal. These two angles are equal. This side and this side is equal. Since AB is greater than DE, so this particular AB is longer than DE. So now we will take one point on this AB, that is point P, in such a way that BP will be equal to ED. Because here we are already considering AB is greater than DE. Here we are already considering AB is greater than DE. So AB will be longer than DE. So we are taking point on AB in such a way that from that point to B will be equal to DE. So that means here PB should be equal to D. So here I'll just write the statement considering point. So we are considering a point P. So we are considering a point P on AB such that here PB is equal to D. So now we have PB is equal to D. So here we'll draw one imaginary line from this particular point P to C. So here you are forming one more triangle inside ABC triangle, that is PCB. So we are getting one PCB triangle. So here since this particular PB is equal to D, because here we have taken point P in such a way that PB is equal to D. Now in triangles, so in triangle PBC and here one more triangle is DEF. So we are considering this inner triangle, this particular inner triangle PBC and DEF. Now here since triangle PBC and triangle DEF are forming, this particular PB is already equal to DE. In these two triangles, PB is already equal to DE. And here this particular angle ABC is equal to DEF. This is already given in the theorem. So ABC is equal to, here ABC is equal to DEF. And in this particular theorem, we already know that BC is equal to EF. This particular triangle BC is equal to EF. So since here you are considering this side, this angle and this side. So according to SAS axiom, here according to SAS axiom, triangle PBC is congruent with triangle DEF. So this is according to SAS axiom. And here if you are considering this particular angle, that is PCB, and if you consider DFE, those two angles will be equal because PBC and DEF are congruent triangles. Since PBC and DEF are congruent triangle, here this is because triangle PBC is congruent with triangle DEF. So in the bracket I am writing the reason. So that means here you can see PCB will be equal to ACB. So that means here PCB, this angle and this particular angle are equal to each other. So that means here this is possible only when P and A coincide with each other. Only this point when it is coinciding with A, then this particular angle and this particular angle will become equal to each other. So therefore P coincides with A. So P coincides with A. Therefore here triangle ABC, because PBC and DEF were congruent triangles. Now P is coinciding with A. So that means again this PBC is nothing but ABC. So that means triangle ABC is congruent with triangle DEF. This is case 2. In case 3, similarly in case 3, you have these two triangles like this. So now in case 3, we are considering AB is less than DE. So in the first case, we took AB is equal to DE, and straight away we got these two triangles are congruent with each other according to SAS axiom. In the second case, we took AB greater than DE, then we took a point in between A and B in such a way that PB will be equal to DE. Now we are considering the third case, third possibility, that is AB is less than DE. So only these three possibilities are there. So now we have proved this. We have proved this. Now we have to prove AB is less than DE. Similarly, how you took point P on AB. Now here AB is shorter, DE is longer. We are considering AB is less than DE. So now you can just consider a point P on this particular DE, and you just connect this P and F. Now you can consider PEF triangle and you can consider ABC triangle. So here this PE will be equal to AB, and this particular angle is already equal to each other. This side is already they have given, which is equal to each other. So according to SAS, ABC and PEF triangle will be equal. So since ABC and PEF are equal, this angle and this angle should be equal to each other. And in the given, they have given that this DEF is also equal to ACB. So DEF is also equal to ACB, and here PFE is also becoming equal to ACB. So how we did for case 2, similarly you have to do in case 3 by taking point P on DEF triangle. In the place of ABC triangle, you are taking point P on DEF triangle, and similarly you are proving. So here also P coincides with D. So this particular ABC and DEF will become congruent triangles. So this particular proof for case 3 you can do on your own. So I have taught how to do for ABC triangle by taking point P on ABC. Now you can take the same point P on DEF triangle for case 3, because here AB is less than DE. You can prove these two triangles are congruent with each other. This is theorem 7.1. So now we will look into the next rule, that is AAS congruence. So now we will look into AAS congruence, that is angle side. So if you are considering two triangles like this, so one is if it is ABC, and if you are considering PQR as the another triangle, then you have to consider, if you are considering this angle, so next angle is this angle, and the next immediate side is this particular side. So angle side, if they are equal to each other, the corresponding angle side are equal to each other of both the triangles, then these two triangles will be congruent with each other. So now we have looked into SAS congruence in my previous video. In this video, in theorem 7.1, we have learnt about ASA congruence. Now you just remember AAS congruence as well. So SAS congruence rule is there, ASA congruence rule is there, AAS congruence rule is also there. So angle side of one triangle is equal to angle side of corresponding angle side of another triangle, then those two triangles will be congruent with each other. Now you have learnt about SAS congruence, AAS congruence, and also ASA congruence. Based on this, we will now solve example 3, and based on this, we will also solve exercise 7.1. So before going into exercise 7.1, we will solve example 3. So in example 3, so there is two straight lines. One is CD and the other straight line is AB. So here CD is parallel to AB, and here C is connected with B and D is connected with A. And here one data they have given, that is O is midpoint of AD. So that means here AO and OD are equal to each other. And they have given CD is parallel to AB. So the data which they have given here is AO is equal to OD and CD is parallel to AB. Based on this data, you have to prove that these two triangles are congruent with each other, and you should also prove that CO is equal to OB. So what we need to prove here in this particular example is that in the first problem you have to prove triangle COD is congruent with triangle AOB, and in the second question in the same example you have to prove OC is equal to OB. So if COD and AOB becomes congruent, then obviously OC will be equal to OB, and if OC is equal to OB, then O is the midpoint for CB as well. So in this figure you can see that this particular CD and AB are parallel to each other. So if they are parallel to each other, then alternating angles should be equal to each other. So these two angles should be equal to each other, and these two angles should also be equal to each other. So that means this angle and side are equal to each other. So that means according to angle side congruence, according to angle side congruence rule, these two triangles are congruent with each other. So we'll just write that in statement form. Since CD is parallel to AB, here CDO should be equal to OAB. So that is this particular angle CDO and OAB. Now you have to consider this angle also, DCO and OBA. So DCO and OBA. So these two angles are equal to each other. So now here you can see they have given one data, that is AO is equal to OD. So that also they have given AO is equal to OD. So that means here we are getting angle side. So according to angle side axiom, so according to angle side congruence rule, here triangle ODC is congruent with triangle AOB. Since triangle, so first question we have proved. So now in the second question, since triangle ODC is congruent with triangle AOB, since triangle ODC is congruent with triangle AOB, therefore here OC is equal to OB, because those two triangles are congruent with each other. Therefore O is also the midpoint. So O is also the midpoint for the line segment CB. So OB is also the midpoint of CB or BC line segment. So we have proved the first question and the second question which is there in this example 3. This is all there in this particular video. The exercise 7.1 questions and the further concepts which are there in this particular chapter I'll be teaching in my next videos. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.